Okay folks, this is my Fukushima redo on the radiation levels using the proper equation this time. As you can tell, we still have our Z equals half-life in years, P equals continuous output, Y equals initial amount or output, D equals amount remaining, that's of the radiation remaining out. And here is why I was messed up last time. I had the ones, these right here, I had accidentally flipped them over. So this time I corrected them. And as you can see, it still says Y divided by P times Z minus 1/2 initial amount plus continuous output times Z minus 1 over Z plus Z minus 2 over Z plus 2Z minus Z over Z. This is for this equation is for strontium 90 and cesium 137 as an example. It can be done with other isotopes. I have considered for an initial amount, I estimated a 1,000 unit amount. That could be 0 and the equation would still work out because it is a plus there. It is not a multiplication or division. So if you decide to put 0 there to see what it would do, you can do that. It will give you the baseline from when an accident occurs and there's no nuclear explosion that causes it. In other words, all it does is melt down. But this one includes an explosion, which is what happened at reactor number 3 at Fukushima. So this is what I'm figuring out. Okay, as you can tell, I've got my equations running there. It's 1,000 units for the 1,000 units plus 100 units by 30 years. And that 1,000 units is units per year, by the way. I forgot to put the year there. Minus 500, which is plus 625. The 625 is the new figure. It's no longer 2,200. As you can tell, that mistake I made really ran up how much that was. It ended up coming up to 1125, so that's about half what it was showing earlier in the previous video. Then you get the first D. It's 4,000 minus 1125 equals 2875. Then D2 goes down to 3812, which is this number right here. That's actual end amount. As you can tell, it keeps going up and then it levels off. See how it goes up to 42, 45, 46, 47, then 47. See how it slowly trails off? Now look at this figure. It's slowly trailing off too. It's starting to go towards 9, up to that 3,000 mark. Well, the 3,000 mark is the amount I allowed for the continuous output. I allowed for 100 units for over 30 years. That's 3,000 units total. So this equation maxes out at that point. And then it's just simply the new continuous output that counts. That would be the reactor's output itself and not the explosion that caused the meltdown. So as you can tell, that kept getting, well, I got 74 there for some reason. It should be 77. As you know, it goes from 77. This right here should be 77 too. There we go. It's 77 now. As you can tell, it gets close to that maximum value of 3,000 for the subtractant, which is this right here. The max it'll hit is 3,000 because that's the max number of continuous output that's put out. As you can tell, it got up to like 380 years, and it's basically leveled off in 210 years. Right here, it basically started leveling off right in this neighborhood here, about 280 to 210 years. And it will be at that 7 by the initial amount value for millions of years on strontium and cesium. Because of the very fact that the reactors themselves use a special type of uranium called uranium-235, which will produce this reaction for 700 and something million years. So that's what I wanted to show you on this new version. Let me back it out here so you can kind of see everything. You can kind of see just how bad it really is, and how bad it'll get. I mean, within my lifetime, I would see probably at most the first 30 years, which is only 2875. As you can tell, it still increases and increases and increases, but it basically levels off like 150, 180 years from now. So this accident's going to go on for quite some time, folks. Well, that's all I had to say. Have a good night.